This is RD Sharma Solution Class 12, Chapter 15. Mean Value Theorems exercise is 15.1. Now we have to apply the Rolle's theorem. Most of the question which we will start with, they are based on the applicability of Rolle's theorem. That is, whether we are able to apply the Rolle's theorem or not in these expressions. Once it is certified, it is established that the Rolle's theorem can be applied, then the Rolle's theorem discussion will go on. Okay. So first we have to understand, you have to go back, you have to revisit where I have discussed about the Rolle's theorem and the mean value theorem, that is MVT, Lagrange's mean value theorem. Now here we have the domain 1 and 3. So we have a function and we have to discuss the applicability of Rolle's function in these interval. What is the interval? 1, 3. That is, it will start with 1 and end with 3. So we have a function fx 3 plus x minus 2 to the power 2 by 3. Now there are certain facts. First is it has to be continuous and differentiable, fa equal to fb, then we can check it. But in this question we are, it's very evident that when we take the f dash x and x to the power n minus 1, what do we get? 2 by 3, 3 goes 0, 2 by 3, x minus 2 to the power 2 by 3 minus 1. That is 2 minus 3 by 3, that is minus 1 by 3. Okay. So x minus 2, the power is negative 1 by 3. So I have differentiated it. And this x minus 2 comes to the denominator. It comes to the denominator. Now when you do the differentiation, you are able to see from your previous discussions also, previous ideas also, that is x minus 2, when x is equal to 2, the denominator will become 0. And in mathematics you have to understand that when we have a 0 in the denominator, if I tell you, say I have 10 pencils and I tell you to divide it into 0 parts, you will be saying, what kind of question is this? So this is the thing, you cannot divide anything by 0. It is infinite, it is undefined. So when you put x equals to 2, the thing will become 0, 1 by 0, and 1 by 0 is nothing but undefined. You cannot divide anything with 0. So when you have an undefined result, that means that when you put x equals to 2, which 2 is lying between 1 and 3. Between 1 and 3 you have 2. Alright, so for 2 it is not defined, and when we are talking about an interval, you have shown the examiner that the range which is 1 and 3, 1 between 3 and 2 you have applied, and there is a problem in the differentiation. You are not able to get the proper result. So the Rolle's theorem cannot be applied. So how you are going to write it, how we have to define and establish the applicability of Rolle's theorem. There are certain more questions we are doing right now. For example, this question. So this is the greatest integer not exceeding x. So it has to be less than x only. Or so greatest integer function, you must understand this. We have discussed it all through our discussions. And there is a domain -1 and 1, and they are inclusive. So this is a closed interval, not an open interval. Now we have to establish the Rolle's theorem, whether it is applicable or not. We have to discuss the applicability of Rolle's theorem in this indicated interval. Okay. First, we have to find out the continuity, then the differentiability. If certain function is not continuous, why would we think about this differentiability? In Rolle's theorem, it has to be continuous, differentiable, then fa equal to fb, that is a and b are the endpoints, or in this case 1, -1 and 1. So we need to establish or find out a point between -1 and 1 where f dash c equal to 0. So we say that there is a c. Let us say we have a point, or we have a value in between -1 and 1, and we assume that c is not an integer, because if you give an integer inside the greatest integer function, it will always give you an integer. There is no point in giving an integer inside a greatest integer to discuss the applicability of Rolle's theorem. So what we'll do here is, we will say that we are taking c, but c is not an integer, but there is a x which is tending to c. That is, when we are trying to find out fx, this is greatest integer function x, it will be fc. That is, the c has to be put inside these square brackets. Okay. Now I will do certain thing here that you will understand, that -1 to 1, if you put c equals to 0, see 0 is in between -1 and 1, no problem with that. When you put c equals to 0, c lies between -1 and 1, it will be 0. But this will not happen, because you have to check 0 minus and 0 plus, that is the left hand limit and right hand limit. As I said, greatest integer function, we should give certain value that gives you an integer, not an integer. Means you should not put or insert any integer. So this 0 minus and 0 plus is the left hand limit and right hand limit. And when we take 0 minus, that is you are going to the left of 0. That is you are talking about -1 and 0. You are going to the left of 0, not to the right of 0. So this is the point where you are going. So greatest integer function will always give you a value which is not exceeding x. So when you will give anything between -1 and 0, you will get a value -1, not 0. That is limit x tends to 0 and left hand limit, that is I am indicating it by 0 minus. So when you put 0 minus, you are not going to get a 0, but in fact you are getting a -1. So this whole scenario here is add 0 or just a point backwards to 0, you are not going to get 0, you are going to get -1. So we are trying to establish or tell you that you have to check for the continuity. This is just, see, left hand limit and right hand limit we have understood in the previous discussion that we are talking about the continuity. So when the function is not continuous, we cannot think about the Rolle's theorem applicability. So if this function is discontinuous at x equals to 0, that is why the Rolle's theorem cannot be applied in these indicated intervals. I don't know, this function may be continuous, differentiable, we can apply Rolle's theorem, doesn't matter. We are talking about -1 and 1. The domain is given and we are pretty sure that between -1 and 1 the function is not continuous. Now we have fx is equal to sine 1 by x, and again we have -1 to 1 as the domain. We have to discuss the applicability of Rolle's theorem for the following function on the indicated intervals. Okay, let me make you recall the Rolle's theorem. There are 2 points, that is you start with one point and when you come back to the same point, you have to take a turn. You can take multiple turns, but at least one turn has to be there to reach the same level, and that turning point is nothing but the f, where f dash c equal to 0, but because at that point the curve is changing, the differentiation or the f dash x will be straight line. So first is continuity, second differentiability, third is fa equals to fb. Here a and b are -1 and 1, and once you are agreed with all these conditions, then f dash c equals to 0. So here in this sine 1 by x, it's pretty evident, it's pretty clear that when you put x is equal to any value between -1 and 1, and my favorite value is what? 0. I always take 0. In the previous question I took 0. So when you put x as 0 in sine 1 by x, that is sine 1 by 0, what do you get? Sine 1 by 0. 1 by 0 is what? We have already discussed. It is infinite. It is undefined. You cannot define anything divided by 0. When that is undefined, this sine function becomes undefined. There is nothing called sine infinite. Is it? There is nothing called sine infinite. So the function is not even continuous in -1 and 1. I don't know about other domains, but this particular domain which the question has provided us, I can very well say that in between -1 and 1, this function is not defined. Okay, so the Rolle's theorem is not applicable for the given function. This is how you are going to write. First thing is sine -1 and 1 is your domain. You put x, any value between -1 and 1. I have taken 0, sine 1 by 0 is sine infinite, undefined, so this is not applicable Rolle's theorem scenario. Okay, now again we have not applied Rolle's theorem as of now. We are just checking the applicability of Rolle's theorem, right? Because continuity, then differentiability, then the domain endpoints value should be equal. Then we apply the Rolle's theorem. Alright, here we have 1 and 3. These are the domain. We have 2x square minus 5x plus 3. Now you will say, oh, this is a polynomial. This is continuous also. This is differentiable also. All is good. Very good. Because polynomial function we already know by our previous discussion that this always happens. It is continuous also. It is differentiable also. So why not to check this function? So in the Rolle's theorem, first we check for the continuity, because this is a polynomial function. It is continuous also, differentiable also. Two condition of Rolle's theorem we have met. 1 and 3, this we call it as a and b, and fa is equal to fb. If it is there, then we have f dash x equals to 0. So there is a c between 1 and 3, that will give you a differentiation as 0. Just let us check fa equal to fb or not. F1 is, I am putting 1 in place of x. Here 2x square minus 5x plus 3, I am putting x as 3. So what do we get? This is 2 minus 5 plus 3. So you get 5 minus 5, 0. This is 9 to the 18 minus 5 to the 15 plus 3, 3 plus 3 is 6. Now FA is not equal to FB. So as I said, continuity differentiability is established. But the third condition for the Rolle's theorem, FA equals to FB, is not satisfied. So we cannot apply Rolle's theorem in this case also. Alright. So this is how you are going to write in your exam. This is how you are going to put this on your paper, because everything has to be written, because if you know things, that will not suffice. You have to put it in the paper in the written form so that examination person can understand, oh, he knows it. Next one is x to the power 2 by 3. Again, the interval is -1 to 1. We have to discuss the applicability. If you remember, the first question was around like this. Okay, it was similar to this one. So, as I said, let us check. We have -1 and 1 as the domain points. This is A and this is B. First, it has to be continuous. Because this is a polynomial function, it is continuous. Second thing, differentiability. I am skeptical about it. Let us check. Let us differentiate it. X to the power 2 by 3. Let us differentiate. What do you get? The first condition is continuous. As I see it as a polynomial, I am saying it as a continuity scenario. How about differentiation? X to the power 2 by 3 is 2 by 3. X to the power 2 by 3 minus 1. So this is 2 minus 3 by 3. That is -1 by 3. So x to the power -1 by 3. Now take this x 1 to the power 1 by 3 in the denominator. So you have 2 by 3, 1 by x to the power 1 by 3. Alright. So this -1 and 1, I am very fond of 0. When I put 0, it becomes undefined. That means it is not differentiable. When you differentiate it, you are getting a value at 0 as undefined. So f dash x is not defined properly in this interval. When f dash x is not defined, differentiability is not established, you can very well say that Rolle's theorem cannot be applied in this indicated interval for fx equals to x to the power 2 by 3. This is what I have explained you. This is what you have to write. Your function just differentiated, because after all these discussions and our prior experience, we know how to do this. X to the power 2 by 3, we are very, very well aware how it is going to respond. Now still we are in the same path that Rolle's theorem can be applied or not, whether the applicability is established or not. So we have this 0 and between 0 and 1, 1 and 2. Between 0 and 1 we have minus 4x plus 5. Between 1 and 2, you have 2x minus 3. So first condition is, if we apply Rolle's theorem, first the thing has to be continuous. Then second thing, to be differentiable. Third function is the FA should be equal to FB. That is F0 equal to F1 and F1 equal to F2, like that. Fourth condition is f dash x equals to 0. What we'll do? We have 0, 1 and 2. My favorite point is to put a 0. Okay, I'm making a number line. But as I see in this question, 1 lies between 0 and 2. So in this Rolle's theorem, we always think and take that value which is between this 0 and 2. So what value we have? We have 1 in between. So we'll check at 1 and we will try to see. And simple thing is, if you are aware of continuity, how to check the continuity of this kind of question, it is pretty clear that you are able to do this kind of question and you can go ahead. But I am just doing the check for the continuity, left hand limit, right hand limit. So I am going to check at 1 minus 1 plus, that is left hand limit of 1 and right hand limit of 1. So limit x tends to 1 minus is what? 1 minus h. You will put 1 minus h in place of x. So when you change you put 1 minus h, the limit h tends to 0. So limit h tends to 0. In place of x, just put 1 minus h. So minus 4 into 1 minus h plus 5. Since you are talking about a value which is below 1, you have to take minus 4x plus 5 as the function. So minus 4 into 1 minus h plus 5. What do you get? Minus 4 into, this is 4h plus 4h. And then we have 5. So this 0, 5 minus 4 is 1. This is the left hand limit. Let us find out the right hand limit. Limit x tends to 1. But this whole continuity concept you know. Okay, this is just a way of recalling it. Limit h tends to 0 in place of now x, just put 1 plus h. Now you are going beyond 1. So you have to take the function 2x minus 3. So 2 plus 2h minus 3, and this is 0. 2 minus 3 is -1. So what do you think? Left hand limit, right hand limit, they are not same. So that means this function is not even continuous. When the function is not even continuous, can you think about Rolle's theorem? The first condition for the Rolle's theorem is the function has to be continuous. It is not continuous. So just see, I am going to pose or present the solution in front of you so that those who want to write it or remember it for their examination, they need to know how you are going to write it. So this is how you are going to write it, and you have to show that this function is discontinuous at x equals to 1 the way we showed with left hand limit and right hand limit. So Rolle's theorem is not applicable for this given function because 1 and minus 1 are not equal. Okay, now we are starting those questions where Rolle's theorems will be actually applied. We are going to apply it here. Any possibility? Yes. So this x square minus 8x plus 12, first good thing is that this is a polynomial. So when fx equals to x square minus 8x plus 12, let us we don't have to prove anything here for the continuity and differentiability because it is continuous and differentiable also. We can see that it's quite clear here, evident here. Then in this range 2 and 6, we will do certain continuity and different. No, we don't need to check it. See, fa equal to fb directly. The third point we are going to check. Fa equals fb. So fa is f2, fb is f6. F2 is simply put 2 in place of x here, x square minus 8x plus 12. Here you put x as 6, so 6 square minus 8 into 6 plus 12. You are going to get here is 4 minus 8 to the 16 plus 12, 12 plus 4, that is 16 minus 16 is 0. Now you have this is 36 minus 6 is 48 plus 12, 12 plus 36 minus 48, again 0. Now the good thing is fa is equal to f. It is continuous, it is differentiable, it has fa equal to fb. A and b are the endpoints of the interval. So all the three conditions for the Rolle's theorem have been met. Now the final thing is there has to be certain value in between this 2 and 6 so that you get the differentiation value as 0. So f dash x, there is a value c. We are going to find it just now. This f dash c will be equal to 0. So differentiation, I am differentiating this function. You have to differentiate it first. X square minus 8x plus 12 is 2x minus 8. 12 will be 0. So this f dash x is simply for this 2x minus 8. And 2x minus 8 has to be put as 0. So you get x equals to this 2 4 side 4. So now this 4 is between 2 and 6 because you are getting f dash 4 as 0. When you put x as 4, you are going to get this function as 0. Differentiation of this function is. And this 4 is actually evidently between 2 and 6. So we have applied the Rolle's theorem. We have checked all the conditions and we are quite satisfied with it. So we started with 2, we ended with 6. In between we got 4 where the graph might have turned. You might have got a straight line parallel to the x-axis or any indented x-axis, that also is proved here. So the next question which are coming, all these are we are going to apply the Rolle's theorem. So this is the whole scenario which I just explained. This is how you are going to write. First you have to say it is a polynomial function. F2 and F6 you are going to find out the value. You will have to say those two values as equal. Then just differentiate the function and put it as 0. Whatever x value you get, it should be between 2 and 6. And in this case it is between 2 and 6. That is why the Rolle's theorem is verified in this case. Okay, this question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.